In today's industrial world, precision and control are everything. If you've ever thought, how do automated systems actually move things? Then this video is for you. From opening valves to powering robotic arms, industrial actuators are behind it all. Let's explore how these powerful devices work and how they connect with PLCs to make automation possible. So, what's in this video? We're covering the fundamentals of industrial actuators, their main types and working principle behind those actuators. Then, we'll cover how PLCs communicate with these devices using PLC output signal. Finally, we'll look at some real-world applications, showing you why actuators are an essential part of any PLC-controlled system. What's an actuator? Well, it's a device that converts energy into physical or mechanical movement. This movement can either be linear or rotary. To make this happen, an actuator needs two things: a power source and a control signal. The power can come from electricity, air, fluid, or even mechanical sources, and the control signal often comes from a PLC or some other controller. In industrial control systems, actuators work as the output mechanism, turning control commands into physical actions. Actuators come in different forms, each built for a specific kind of movement and force. They're designed for high precision, repeatability, and efficiency, making them perfect for various automated tasks. Let's break down the types of actuators and take a look at how each type works. Let's talk about electric actuators. Electric actuators are powered by electricity, which enables them to produce precise linear or rotary motion. They operate on a simple but powerful principle, converting electrical energy into mechanical motion. Here's how it works. An electric motor, either AC or DC, depending on the application, takes electrical energy and spins a shaft, creating rotational motion. From there, this rotation is transmitted through gears, like worm or planetary gears, to produce a specific type of movement. Servo motors and stepper motors are the example for electric actuator. Contactor and relay are among the most commonly used output devices in a PLC setup when working with electric actuators that require a simple on-off signal. Pneumatic actuators use compressed air to create movement, which can be either linear or rotary. A common example is a pneumatic cylinder. Here's the basic idea. When air pressure enters the actuator's chamber, it generates a force that moves a piston or diaphragm. This movement happens within the actuator's cylinder, and the direction and pressure of the air are regulated by control valves. These valves are crucial for managing the actuator's position and speed. There are two main types of pneumatic actuators. Single-acting actuators. These use compressed air in one direction, while a spring or similar mechanism returns the actuator to its starting position. Double-acting actuators. These use compressed air for both extension and retraction, allowing for controlled movement in both directions. Hydraulic actuators use fluid pressure, usually oil, to generate powerful motion, making them perfect for heavy-duty tasks where a strong force is needed to handle large loads. Here's how they work. Hydraulic actuators supply pressurized fluid into the chamber, creating force that drives movement, depending on the design. This pressure can push a piston in a straight line or rotate a vane, allowing for different types of motion. There are two types as linear actuator and rotary actuator. This is how linear actuator works. In a hydraulic cylinder, the pressurized fluid moves a piston in a straight line, ideal for pushing or pulling heavy loads. In a rotary hydraulic actuator, the fluid pressure acts on a vane or vanes, creating rotational movement and producing torque. Mechanical actuators are devices designed to convert rotary motion into linear motion. They achieve this by using mechanisms like gears, screws, levers, or cams to transform input energy into controlled mechanical movement. This input energy can come from various sources, such as manual effort, like turning a screw or handle, an electric motor, or even another type of actuator. Let's see how PLC communicate with actuators. In industrial automation, actuators are controlled to turn on or off based on the system's needs. When an actuator is activated, it performs its specific function, and automation takes place. For actuators to operate, they need a power source and a control signal that tells them when to activate. This control signal is sent from a controller, like a PLC. Let's go through some common ways PLCs control actuators. In PLC systems, there are three common methods for controlling actuators: digital signal method, analog signal method, and PWM, pulse width modulation method. Let's take a closer look at each method. In the digital output control method, actuators operate in two states, on or off, also called binary mode. For example, a solenoid valve can open or close based on a 2,4 VDC signal from a PLC output, which fully turns the actuator on or off. In this setup, 24 DC volt power is supplied to the solenoid valve via the PLC, allowing it to open and close the air pressure to a pneumatic cylinder. For actuators that only need on-off control, PLCs commonly use relays and contactors as output devices. When higher voltage is required, like with three-phase power, contactors are typically used. In analog signal control method, actuators can be opened and closed to a specific position. For example, if you need to control a valve open to a specific position, like halfway, analog signals are used. These signals can vary to control actuators that require adjustable outputs rather than just on/off. In this example, the butterfly valve can be positioned precisely to specific levels, such as 25%, 75%, or fully open. Another control method is pulse width modulation signal. Pulse width modulation, short for PWM, is often used to control the speed of a DC motor. For example, if you need the motor to turn a specific number of times, a PWM control signal adjusts the actuator's operation to achieve precise control. Hello viewers, if you're not familiar with any terms mentioned, please drop a comment below and we'll make sure to cover them in future videos. Industrial actuators are essential in various automation tasks. Here are some common applications. Conveyor belts. In packaging plants, actuators control the speed and direction of conveyor belts, moving products through different stages of assembly, inspection, and packaging. Robotic arms. In automotive manufacturing, robotic arms equipped with electric motors or hydraulic actuators assemble components like engines, doors, or chassis parts. Industrial valves. In chemical plants, pneumatic actuators manage the opening and closing of valves, regulating the flow of chemicals into reactors or storage tanks. Pneumatic cylinders in material handling. On assembly lines, pneumatic cylinders help pick and place items or push products along a conveyor system for the next stage of processing. CNC machines. Actuators like electric stepper motors, servo motors, and linear actuators are used in CNC machines, allowing them to cut, mill, or drill materials like metal and plastic with precision. In this video, we explored the fundamentals of industrial actuators, from their different types to how they function and integrate with PLCs in various applications. We covered the following key points. First, we discussed overview of industrial actuators. Actuators are devices that convert electrical, hydraulic, or pneumatic energy into mechanical motion, driving industrial equipment and processes. Then we discussed types of actuators. We looked at the main types of actuators: electric, pneumatic, and hydraulic, each suited for specific tasks and offering unique benefits in terms of control, force, and application. Next, we discussed working principles. Each type of actuator operates differently. For example, electric actuators use motors to drive motion, while hydraulic actuators rely on fluid pressure to generate force. After that, we went through how actuators integrate with PLCs. There are several ways PLCs send signals to actuators. These include digital signals, for simple on-off control commonly used with relays or solenoids. Analog signals, for precise adjustments using variable signals such as 4 to 20 mA or 0 to 10 volt. PWM, pulse width modulation, for applications requiring fine control such as motor speed adjustments in electric actuators. Finally, we discussed common applications. We discussed practical examples of actuators such as conveyor belt, robot arm, pneumatic control valve and CNC machines that use DC motor and servo motor for precise adjustments.